A two-step experiment means you're doing more than one thing. For example, I might be flipping two coins. This table here shows the outcomes. I can get a head with the first coin and a head with the second, a tail with the first coin and a head with the second, head, tail, and tail, tail. There are 4 outcomes, and so I can use that to help me work out probabilities. The probability of getting 2 heads is 1 out of 4, because there's one way of getting 2 heads and there is 4 possible outcomes. The probability of getting 1 tail is actually 2 out of 4, and that's because I can get 1 tail here and 1 tail here. And that ends up being a half. The probability of getting a head and then a tail is actually only equal to 1 over 4, because I have to get the head first and then the tail second. I can't get the tail and then the head. And the probability of getting at least 1 head means that I need to have a head in any of the outcomes. All 3 of these have got a head in them. So the probability of getting at least 1 head is 3 out of 4. Sometimes when we do experiments, what we do affects the probability as we go along. Let's look at an example. Here I've got a bag. Now normally you wouldn't be able to see what's inside the bag because we're going to put our hand in and pull one out. So just pretend this is all coloured in and you can't see these beads inside the bag. And I've got 2 green, 2 brown and 3 blue beans in the bag. And if I was saying the probability of getting a brown, I would write the probability of getting a brown is equal to 2 out of 1, 2, 3, 4, 5, 6, 7, 2 sevenths. However, if I now take that brown, I've taken the brown out and looked at it. If I put it back, the probability of getting brown the next time I do the experiment stays 2 sevenths. And that's called with the replacement. I've replaced the brown back in the bag. I took it out to see what it was, and the probability of me getting it the first time is 2 sevenths. Then I've put it back. So the next time I pull a bead out of the bag, the probability of getting a brown stays 2 sevenths. But if I take the bead out and don't put it back, then I've changed what's in the bag. So now I only have 1 brown in here. So the second time I do this experiment, if I don't replace it, I get a new probability. This is the second go. The probability is going to be only 1 out of 6. So you notice that the number of browns has gone down by 1 because I took one out, and the number of the total balls in the bag, or beads in the bag, has gone down by 1 as well. So instead of having 2 sevenths the second time, I've now got a probability of 1/6. So let's have a look at calculating some probabilities when I take these beads out of this bag and replace them each time I take one out. So first of all, what I'm going to do is use this tree diagram. It's called a tree diagram because it has branches like a tree that's spread out. The first branching is showing my first event, taking the first bead out of the bag. And there are 2 things that can happen. I can get a blue or a green. So this section here is the first trial, the first time I take something out, and it goes all the way down here. So all these things are the possibilities in the first trial. The possibilities are I could get a blue or a green. If I get a blue the first time, then when I do my second trial and take another bead out, I've again got 2 possibilities. I could get a blue and a green. And that's the second trial. So you can see this tree diagram shows me all the things that could happen. I can get a blue and then another blue, a blue and then a green and then a blue, or a green and a green. If we were to work out the probabilities of those to happen, we need to give probabilities to each of the different trials. So what you do is you look at the first trial. There are 5 beads. the chance of getting a blue is 3 out of 5. So I'm going to write that there. The chance of getting a green is 2 out of 5. 2 greens, 5 balls. Notice that 3/5 and 2/5 adds up to 1, 5/5. If I'm following this path along here, and I've already taken a blue ball out and replaced it or returned it back in, then what can happen is I can get a blue the second time or a green. Still got a blues and greens in the bag. For this second trial here, which is all of these possibilities down here, trial 2, I can get a blue again, and that's a 3/5 chance of getting a blue, or a 2/5 chance of getting a green. If I follow this path, the same thing happens. 3/5 and 2/5. To work out the probability of getting 2 events in a row, we use this rule up here. The probability of A intersection B is probability of A times probability of B. And that will work in this case because the 2 events are independent of each other. Okay, so let's have a look at the first one. The probability of getting a blue and another blue is the probability of multiplying those 2 answers together. So the probability of blue intersection blue is equal to 3/5 by 3/5, which is 9/25. If I keep going down this second trial, I'll be multiplying 3/5 by 2/5, 2/5 by 3/5, and 2/5 by 2/5, which means I'll get 4/25 for getting green, 6/25 for getting green and then blue, and 6/25 for getting blue and then green. Adding all those up will give me 25/25. If I don't replace the beads as I take them out, then the probabilities change. You can see on this tree diagram that if I take the blue one out, the first blue one, there are 3 to choose from out of the 5. But because this one's no longer in the bag, when I take the second bead out, there are only 2 blues left and only 4 beads in total. There are still 2 greens and 4 beads in total. So now the probability of a blue and a green is the same once I've taken a blue out. If I take a green out, the first time there are 5 beads and there are 2 greens, so there's 2 chances in 5. After that there's 1 green less. So that means I'll still have 3 blues out of the 4 that are left, but only 1 green left. So the probabilities when you don't replace the beads change. And of course, the end result is that the probabilities for blue and then another blue, or blue and then a green, are different than in the previous slide. When we don't replace them, we're going to get these answers. I'm going to get 3/5 by 2/4, 3/5 by 2/4, 2/5 by 3/4, and 2/5 by 1/4. And those answers will be different than the answers on the previous slide because we're not putting the first bead back, and the number of beads in the bag changes as we take them out. Another way of showing what can happen when we have 2 events is to actually use a table. In this table here, we're rolling 2 dice. Along the top here, I've got 1 dice, 1, 2, 3, 4, 5, 6. Down the left, I've got the other dice, 1, 2, 3, 4, 5, 6. I can get 2 1s, a 1 and a 2, a 1 and a 3, etc. We can use this to help us work out what the probabilities are of getting certain outcomes from the 2 dice. So let's have a look at the first one. The probability of getting 2 1s. That's going to be equal to 1 out of 36. There is only one result that has 2 1s. There are 6 by 6, 36 total outcomes. 1 favourable outcome, 36 possible outcomes. Now let's look at the next one, which is actually getting at least 1 4. To get a 4, I need to be in this column or in this row. Now there are 6 in each, but one of those is used twice, so it's actually only 11 possible favourable outcomes. So the probability is going to be 11 over 36. And in the last one, a number less than 3, well, there's quite a few places where the number is less than 3. These two rows and these two columns all have a number in them that's less than 3. So the probability of getting that is 20 over 36, because there are 20 numbers here and there is only 16 here. That means 20 over 36 is a probability of getting a number less than 3, which turns out to be 5/9. There are some games like Monopoly where you roll 2 dice and then you add the 2 numbers on the 2 dice together to get a total. So in this table here, I've shown the different totals you can get depending on what you roll. If you roll 2 1s, the total is 2. If you roll 2 6s, the total is 12, etc. You notice that with this arrangement, there are a lot more 7s than any other total. Let's work out some probabilities. The probability of getting a total of 2 is 1 out of 36. There is only one total of 2. The probability of getting a double is where you get 2 numbers the same. That's these ones in this diagonal along here. So you can see there's 6 of those, because you can have 2 1s, 2 2s, 2 3s, etc. So the answer to that is 6 over 36, or 1/6. The probability of a total greater than 10 just means we need to have these 3 here, which would be 3 out of 36, which is 1/12.